Hi everyone and welcome to A-Level Revision with MFS. In this video we look at index laws. Our agenda for the day is going to run like this: rules of indices, then we're going to zoom in onto the structure of indices, and then we're going to finish off with some exam style questions. Please ensure you hit the subscribe button and the notification bell to ensure you never miss a video from A-Level Revision with MFS. So we're going to start now, and we're going to start off by looking at the structure of indices. So over here, the main number that we have in the middle, or term, it could be an x or a y, is called the base. That's what we refer to as the middle number. The power is referred to as the whole, base and exponent, and the exponent is the small number which is raised to the base. Okay, so for example, 6 squared would mean 6 times 6. The exponent tells you how many times the base number is repeating itself. So in this case, the exponent is 2, so that means the base number is being multiplied by itself 2 times. The power is both the base and the exponent, and the base is the main term or the main number. Now there are some indice rules which you need to follow, and I've placed them on this slide over here. When the base is the same, so for example we've got a, and the two powers are being multiplied, you can add the two exponents. So for example, we know our base is a over here, and it's the same in both cases. We're multiplying, and because they are the same, we can add the two exponents. So our end result would be a to the power of m plus n. For example, if we had x to the power of 4 multiplied by x to the power of 3, in this example you can see that the base terms are the same. So we've got x and we've got x. We're multiplying it, so that means we can add our exponents. So that would get us a result of x to the power of 4 add 3, which is 7. The same concept with division. When we have the same bases, so in this case we have a and a, we can subtract the exponents. So if we go back to our first example, let's say we had x to the power of 4 divided by x to the power of 3. Because our base terms are the same, we have x's in both, and we're dividing, that means we can subtract these two exponents, and that would get us x to the power of 1, which we would just write as x. When we have brackets and we have a base and an exponent, and we have an exponent outside the brackets, what we can do is we can multiply the two exponents. Okay, so in this case, we've got a as our base, we've got the exponent m, and we have brackets around it, and then another exponent n. What we can do is we can multiply both exponents, and that would get us our answer. If we had x to the power of 4 brackets 3, all that means is we have x to the power of 4 multiplied by x to the power of 4 multiplied by x to the power of 4 3 times. And because we're multiplying and all the bases are the same, we would just add the exponents. So 4 add 4 add 4, and that would get us an answer of x to the power of 12. Now, because we have brackets, we could have done this much quicker. We could have just multiplied the two exponents. When we have two exponents next to each other, we can just multiply them, just like that. And that would get us x to the power of 4 times 3, which is 12. And as you can see, that is the same as that. And finally, when you have two different bases inside the brackets and the exponent on the outside, as you can see, we have our bases sort of here, and we have our exponent only 1 on the outside, that means each of our bases has the exponent which is on the outside. So ab to the power of n means a to the power of n and b to the power of n. Everything inside the brackets is to the power of the exponent which is on the outside. For example, let's say we had x, y to the power of 4. What that means is everything inside the brackets, because we don't have any exponents, everything inside these brackets, so the bases, will be raised to the power of 4. So this would be the same as x to the power of 4 and y to the power of 4. Okay? So those are the 4 key indices rules that you need to be familiar with. We're now going to have a look at some examples of what you could be asked in an exam. So here's the first one. So it says simplify x cubed minus 2x divided by 3x squared. Now whenever you have more than one sort of term on the numerator and you only have one term on the denominator, you can split this up just to make life much easier. So we can split this up into x cubed divided by 3x squared subtract 2x divided by 3x squared. That is much more manageable than what we had originally. Okay, now we know that if we deal with this first fraction first, we know that's the same as x cubed divided by 3x squared. Our base term is the same. As you can see, we have x's, but we have a different amount. That doesn't really matter. What matters is that we have the same term. Okay, and because we have the same term, we can subtract the exponent. Okay, so at the top we have x cubed and at the bottom we have x squared. That means we're going to get rid of everything at the bottom because we have one more x term at the top. So that's going to leave us with x at the top over 3 at the bottom. Because we've got 3 x's at the top and we've only got 2 x's, so that means we can get rid of the x squared and be left with 1 x at the top. All we've done is x cubed subtract x squared. So we've subtracted the exponents and that's left us with just x. And 3 is the number at the bottom. We don't have a number at the top, so we can't simplify it. So that would be x over 3 or a third x. Now if we deal with our second fraction over here, we have 2x over 3x squared. Now that's the same as 2x divided by 3x squared. Again, we have the same base term. We have x and x, so that means we can subtract the powers. Now, if we have just x, that's like saying x to the power of 1. Okay, so we can subtract the powers and we would get minus 1. So if we go back to this fraction over here, because we're getting minus 1, we can take off the top term because we really have x at the top. Because we've taken 1x from the top, we can take 1x from the bottom. And that would leave us with 2 over 3x because we've got rid of the x at the top and 1x from the bottom, and we've simplified the x terms. Now 2 and 3 can't be simplified any further, so our answer would just be 2 over 3x. Now if we combine them together, we have 1/3 x and we have 2/3x, and they're being subtracted. So putting them together, we've got 1/3 x, or x/3 minus 2/3x. Now bear in mind, you can't have 2/3 x because 2/3 x is different to 2/3x. 2/3 x is like saying 2x/3. So make sure you have the x at the bottom in this case. You can only place the x in a position like this when the x is on the numerator. So this would be our answer. Another question: simplify a cubed all to the squared multiplied by 2a squared. So an important indice rule, whenever we have something like this, let's deal with this first. So we've got a cubed all squared. Now as you can see from this, you have two exponents together, which means you can multiply them. Okay, so 3 multiplied by 2 is going to give us 6, so this will just be a to the power of 6. You could write it another way just to check your answer, because a cubed to the power of 2 is the same as saying a cubed times a cubed. So a cubed multiplied by a cubed. And because we have the same base terms, we can add the powers. That would also give us a to the power of 6. So we know that this is correct. So we've solved the first part. Now the second part, there's nothing much we can do about that. So let's take our first part, a to the power of 6 multiplied by 2a to the power of 2. We have our same bases, so we've got a and we've got a. That means we can multiply it, and when we're multiplying it, we have to add the exponents. So we would have 2a to the power of 8. Okay, and that would be our final answer. Okay, final question. If you want to have a go at it, you can pause the video and have a go at it. Okay, so again, because we have 2 terms on the numerator and only 1 term on the denominator, the easiest thing to do here would be to split the fraction. So we can split this into 2x divided by 4x cubed, and we can split into x to the power of 5 divided by 4x cubed. Okay, now 2x divided by 4x cubed, there's only one x term at the top and 3 x terms at the bottom, so we can get rid of the top x and change this into an x squared. Can we simplify the numbers? Yes, we can. 2/4 is equivalent to a half, so we can change that to a half. Okay, so what we're left with is we have a half x squared. Okay, so we've done the first part. There we have it. And now if we have a look at the second part, we've got x to the power of 5 divided by 4x cubed. With the x terms, we've got x cubed and x to the power of 5. Now we can get rid of all the bottom x terms because we have more than enough at the top. So we can get rid of all of them, and because we're getting rid of 3 x terms, we would have to get rid of 3 x terms at the top. That would leave us with x squared. Okay, and numbers, we have an invisible 1 here because that's just how it is. We have x to the power of 5. How many times? We have it 1 time. And 1/4 can't be simplified any further. So you could have a quarter x squared, or you could have had x squared over 4. Either, it doesn't really matter. So combining them together, we're adding, so it's going to be a half x squared add x squared over 4. Okay, and that's what our answer would be. Now there is another way to write this out. but we will go through this in another video. Over here we've got an x squared term at the bottom. Now it's not normally really good to have an x squared term at the bottom, so what we can do is we can find the negative reciprocal of it, okay, of the x squared term. So we can also write that as a half x to the power of -2 plus a quarter x squared, okay, just so we don't have the x squared at the bottom, but you could have had either answers. Don't worry about this method, we will cover it in another video. Okay, and that's it for this video. Thanks for watching. I hope you liked it, and one last thing, please subscribe, hit the like button and the notification bell.